Okay, so today we're going to talk about static variables and static methods, and essentially the formal name for static variables and static methods are class variables and class methods, because when you say that something is static, you are saying that that attribute or that thing is applicable to the entire class and not to individual objects of that class. So I think a good example is if you try to make the game Space Invaders. I don't know if you ever played it, but it's a video game where lots of little space aliens come down and you try to shoot them. And there are lots of little invaders, so you create a class called Invader. So this class is going to represent the little aliens that come down. Each invader, there will be lots of them, dozens of them, is going to have its own X position, it's going to have its own Y position, and what happens, they kind of tilt left and then back, they tilt back and forth, left and right, left and right, left and right. So they'll always have a current state whether they're tilting left or not. So I've created these three little instance variables. In a real game you'd have more, but we're just going to start with that. Every single invader has its own particular value for these three attributes. They're different for each one. Now, on the other hand, there are a few attributes that are for all invaders all the time. They all share them as common attributes. So, for example, in this Space Invaders game, I don't know if you've ever seen it, but basically all the invaders move at the exact same speed in kind of like this giant block, right? It's like this block of invaders coming down. Since they all move at the same speed all the time throughout the game, you don't need a different speed for each invader. In fact, it would be kind of silly. So what you do is you'd say, I'm going to create another attribute, but I'm going to call this a static attribute. Public static int invader. And since it's static and it belongs to the entire class, you don't want it to be assigned inside a constructor, because a constructor is going to be called every time a new invader is created. So for static variables, we actually assign their initial values explicitly right at the top of the class. That's the idea. What's another example? Let's so you get invader speed. Well, another thing you'll have is the invaders, what happens as the game progresses, the invaders start closer and closer to Earth. So maybe what we want to have is an integer that represents how close to the ground the whole level starts. So the idea here is, the invaders at the beginning of the game will start really high to give the player more time, but then as the player progresses, they'll start lower and lower, and so this will change, but it'll change for all the invaders every time the level advances. Another thing that's common for all the invaders, what happens is since they move in this big block, every time one invader reaches the right edge of the screen, they all turn around and go the other direction. And when they hit the left edge of the screen, they all turn and go the other direction. So they all share a common boundary. So maybe you'd say static. So the idea here is the instance variables at the top, as we studied for a long time ago, are going to be distributed in such a way that each invader object has its own particular values for these variables. However, anything that is static is shared. So all invaders share a single value for static variables. Now, an invader can change these values. So, for example, if maybe enough invaders are killed, maybe they speed up. And so you would say invader speed plus plus, and that would cause the invader speed value for all invaders to increase. So the whole point is that there's just one copy of anything that is static, and that's how it works. Now, in order to have like accessor methods for these, you have to access static variables through static methods. So if I zoom down here, public so it looks exactly the same as an ordinary get method, right? Like here, this is my get method for the isTiltingLeft variable. I'm just returning it straight up. And this is my get method for the static variable invader speed. You just have to declare that the entire method is static up here in the method signature. And again, this means that this method has to be called from the entire class, not from an individual invader object. So for example, if I wanted to execute this, let's say I want to say, right, presumably in this I'm outside the invader class. In order to find out what the speed is, I'd have to ask the entire class. So I say invader.get invader speed. So the idea is, since I've defined get invader speed as a static method, when I execute it from outside the class, I have to execute it on the entire class, not on a particular behavior. On a particular invader. And that's in contrast to if I wanted to ask a particular invader what its X position was, I'd have to get a variable, right? That's how you'd have to call it. So you'd have to have one specific invader's variable and then call the getter method, just as we've seen before. This bottom line is a review, right? We've been doing this all year so far. This top line is new, and that's how you execute static methods on a class. Now, one other thing that you're going to see a lot of is frequently static variables are used as constants. They're frequently values that never ever change throughout a game, and so we create a English-like name for them. So for example, in the math class, the value of pi never changes. So there, you could say math.pi, and that represents 3.14159 for a lot of digits. There are other constants that you could use. In grid world, there are location constants. So you could say location.north, and that represents the number 0 because north is the 0 direction. Similarly, there's east, right? That would be 90. And so there are all these constants that represent numbers so that you can make your code more readable. So in this case, if I wanted to create a constant for invaders, let's say I wanted to always know how many invaders there were in a particular row of invaders. I might say public static final. So notice that, static. So again, I'm making it static because the idea is that we want, there's only going to be one number of invaders per row at any given time. Now, as soon as I say that something is final, I'm declaring a second attribute. Final means that Java will make sure that the value of this variable never changes at all while the program is running. So no part of my code will ever be able to set a different value for this. Therefore, we don't really call this a variable anymore, right? If the value can't change, it's not a variable. So we now call it a constant. So when something is declared final, we make it a constant. Frequently, since this value is never going to change, we usually don't need more than one copy of it, so they're almost always static. Also, since it's impossible to change the value of these, we're not worried about somebody accidentally setting it to something else, so we don't have to make it private anymore. So usually when something is final, it is also static and it is also public. So you'll usually see constants declared as public, static, and final, and then you'll have some data type. So like the number of invaders per row might be 12, and maybe we want to play around with what the initial speed is for different kinds of levels. So what we'll have is an initial speed. So like this invader initial speed will be the speed of the invader in the very first level, but then maybe it'll be easier for us to adjust if we always have this available to us as a single constant. Okay, so I went ahead and opened up the location class from Grid World so you can take a look at it. You see all this commenting, and then see public class location. Don't worry about what that next thing says. And then there's two instance variables for a location. A location has a row and a column. So every single individual location object has its own personal row and its own personal column, and that makes sense to us. But then all location objects share some information. For example, an int called left is static, which means that all location objects have access to this variable equally. It's also declared final because we're not going to change the value of left at all. Notice that left is -90, which kind of should be familiar from what we've seen from Gridfold so far. Similarly, there's a right, there's a half left, a half right. Oh, by the way, I don't think I said this explicitly. When something is final, we tend to put it in all caps to kind of emphasize that this cannot be changed, that it's a constant and not a variable. It kind of shouts out to the human reader that this is a constant. So you'll see all these, look, right, half left, half right, full circle, half circle, ahead. All these are public static final variables that are available, and they're all public, so you can access these as well. Now, if you access them from outside the class, you'll have to write location.north, location.northeast, but inside the class, you don't have to. Here's the constructor for location, so you see R is assigned to row, C is assigned to column, get row, get call, very predictable. Here's another class from Grid World. It's the world class. This is one you really don't have to know very well, but it's got an example of a static variable, so I opened it up. So notice that everything that is a world will have a grid, or it'll have a set of occupant class names, a set of grid class names. It'll have a message, it'll have its own JFrame. Every single world has one of these, but there's a random generator. Essentially, this generator creates random numbers, and it's static, which means all worlds are always going to share the same random generator. And this is a good thing because it means that, well, first of all, there's no reason to create new random generators, right? If the job of this generator is just to create random numbers, all of the worlds could share it, and that's not a problem. But by having lots of worlds sharing the same random number generator, it actually makes the numbers more random because there's an unpredictable pattern of access. So it actually probably improves the performance of the random number generator itself. Also notice that there are more static final variables as well. The default number of rows and the default number of columns is set at 10, and that will never change while the program is running. If you want to change it, you'd have to stop it, change the source code, and recompile the whole program. So again, as a reminder of how we use static variables once they're already made, I've gone and made this invader client class. By the way, the word client means it's a class that uses another class. So invader is a class we've already made. This client class is going to use the invader class. So notice I've created a method called test_invader class, which is what we're going to do. It happens to be static because I don't need any objects to run it. I just want to kind of run it on its own separately, straight out of the class. Therefore, I declare it static. So the first thing I've done is create an invader object. Its x position will be 100. Its y position will be 200. Now I've created a second invader. Its x position will be 300 and its y position will be 400. So now I'm going to create an int called xpos, and I'm going to go into the first invader and get that x position. Then I'm going to print it up. Then I'm going to take xpos and I'm going to get the x position out of invader 2, and you'll see that those are different values. But now, in order to get the invader speed, you see I have to ask the entire invader class what the invader speed is, because getInvaderSpeed is a static method, and static things operate from the entire class, not from individual objects. So you wouldn't be asking invader 1 or invader 2 for their speed, because all invaders share the same speed. So I'm going to compile, and sure enough, there it is, 100, 300, and 4, just like we programmed it. Okay, that's a good start to static methods, and we'll talk more about it in class tomorrow.